All right, ladies and gents, we are moving on. We're going to skip 5.23 because 5.23 is just using our number line and breaking down fractions. We're going to do that again today. So I combined 23 and 24. So I guess you could say we're doing both of them today. I promise the video won't be too long. Our objective is to decompose and compose fractions greater than 1 and express them in different forms. So the first thing I'm going to ask you guys to do is I'm going to ask you to go ahead and write 7/3 and tell me how many thirds make a whole. All right, if you said 3/3 equals a whole, you are correct. So what we're going to do is we're actually going to try and take out as many wholes as possible, but we're going to take them out in fraction form. So how many thirds make 2 wholes? Well, that would be 6/3, right? How many thirds make 3 wholes? That's 9/3. So right there we notice that we can only pull 2 wholes out of 7/3. But as I said, we're pulling them as a fraction. So let's go ahead and take that 6/3. And if you want to write a 2 next to it and just kind of circle it so you know it's worth 2 wholes, that's fine. Just kind of put an equal sign there so you know it's not 2 and 6/3. So what do I have left? If I take out 6/3 from 7/3, what's left? Well, that would be 1/3. Now what I can do is I can say, okay, what does 6/3 equal? Well, that equals 2 wholes. And I just bring over my 1/3. What we're going to do now is we're actually going to look at it on a number line. So go ahead and draw your number line out. We start at 0. Who thinks they know what my endpoint is going to be? Well, if you said 3, you're correct, because 2 is between 0 and 3, obviously. What are we working with? We're working with thirds. But first we have to find our wholes. So if we have 3 as our distance, we're actually going to cut it into thirds. And that's going to be a 1 and a 2. Please cut each of your wholes into thirds. Pause while you do it. Here's what your number line should look like. You should have thirds in each whole. So we're going to start at 0, and we're going to jump 6/3 first. So we're trying to figure out how to break down that 7/3. Well, we know we took out 6/3, which is 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, or you just go because 6/3 is equal to 2 wholes. We figured that out by counting it up here. And then we do one more little hop for 1/3. So this equaled 6/3, and this equals 1/3. So we have just proven that 6/3 plus 1/3 really truly equals 2 and a third. We're going to do the same thing with 13/5. Again, asking ourselves how many fifths are in a whole. Go ahead and do what we did up here, figuring out how many fifths are in 1 whole, 2 whole, 3 whole, till you kind of run out of pieces. All right, so I'll start you off. 5/5 equals 1 whole. But I can keep going because I have 13. Pause while you do this. Hopefully you stopped at 3 wholes because 15/5 is more than what we have. So what we're going to do is we're going to pull out as much as we can for a whole, which is 10/5. Again, if you need to write 2 equals next to it, that's fine. Ask yourself what's left, and then come up with your mixed number. Pause while you do this. Hopefully you came up with 2 and 3/5 as your mixed number because 10/5 equals 2. Bring down your 3/5. What I'd like you to do now is I'd like you to plot it on that number line just like we did up here. Our endpoints are 0 and 3 again. Look at that. Because 2 falls between 0 and 3. Again, cut your wholes, but this time we're working with fifths. So you'll separate each whole into fifths. If you want to hop your 2 wholes and then 3/5, go ahead. If not, you can wait for me. Pause while you split each of these wholes into fifths. I cut each hole into fifths by drawing 4 lines that were spaced apart evenly, because 4 lines equals 5 groups. So we count our spaces, not our lines. So I'm going to hop for 10/5. Well, I can hop each one till I have 10. 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, or I can just do a big old hop, which equals 10/5, and then 1/5, 2/5, 3/5. So it proves that 13/5 equals 10/5 plus 3/5, which equals 2 3/5. The last part of this lesson is taking our fraction into a mixed number and using multiplication to create it. So here's our improper fraction, 7/3. How many groups of 3/3 are in 7/3? Well, we found last time that there are 2 groups of 3/3. So we're going to pull out 2 groups of 3/3, because that gives us 6/3, right? Does that give us 6/3? Yeah, 2 groups of 3/3 gives us 6/3. But wait a minute, I didn't use them all. Oh, that's right. There's 1/3 left. So 2 groups of 3/3 is 2, because 3/3 is a whole, isn't it? So 2 groups of 3/3 is worth 2. Or you could say it's worth 6/3, which is the same as 2. And then you add your 1/3 in. And then that equals 2 1/3. That's another way to show it with multiplication instead of breaking it down into that number bond. We're going to do the last one, which is 10/4. How many groups of 4/4 can you get out of 10/4? Go ahead and do it off to the side like we did before. Pause while you do it. You should have found that we can only go to 2 groups of 4/4. So we know that I have 2 groups of 4/4. But what's left? Because 2 groups of 4/4 is 8/4. So what's left? Well, if you take 8 from 10, you get 2/4 left. Then what you're going to do is you're going to say 2 times 4/4. Well, it's like saying 2 times 1. So it's 2 plus 2/4. And then you just put it together, because 2 plus 2/4 is 2 2/4. What I'm going to do now is I'm going to write an expression a little bit differently. Watch how I do this. 10/4 equals 2 times 4/4. That's the same thing as this, plus 2/4. You can still solve this, you can still solve this the same way. 2 times 4 is still 8/4, which is still 2. 8/4 plus 2/4. Bring down that 2/4. You get the same answer. It's kind of what they're going to be looking for today, to see if you can break down in a couple different ways. Go ahead and find a partner to work on this video with, to work on your problem set with, and good luck.